So I realized that in this previous exercise, I forgot to do this. Zero is very important here in the fundamental theorem of calculus. I forgot to subtract off 0 to the fifth power over 5. Whew, man, I almost missed this question. It's lucky that I came back and I fixed my mistake. Okay, then I think it's time to move on to exercise 3. I'm pretty sure it's piece of candy. Find the volume of the solid form by revolving the region bounded by y equals half x minus 1, y equals 0, y equals 2, x equals 0. About the y-axis, finally, we have a vertical axis of revolution. We'll see how that affects stuff. So we'll start as we've done before with a picture. Okay. All right, so we're going to go around the y-axis. So I need something kind of roughly cylindrical. And then our function here is 1/2 x minus 1, this color. Minus 1, I'm going to say that that's about like right there. So it'd be up 1 over 1, 2. So here's our line. Okay, voila. All right, it has y equals 0, which is basically the x-axis. Y equals 2, so I need to go up 2 for a vertical line. Oh, here we go. And x equals 0, there's the y-axis, of course. So it's this trapezoidal region that we are going to revolve around. This time, the y-axis. Come on, color in the lines. Make it look nice. It's professional. It's going on YouTube. All right, again, we're going to revolve this thing around the y-axis. It is this time, if you think of your representative rectangle, it's got to be perpendicular to that axis, so it's going to be horizontal this time, sort of like this. Doop, 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 doop. And as we've seen before, you need two pieces of information to find the volume of a said rectangular slice whenever you revolve it around to make the disk. You need a height. So the height this time is we're partitioning the interval on the y-axis from 0 to 2, so it's a delta y. Okay, and then here is going to be the radius of our disk. Well, speaking of radius of disk, why don't I draw my disk in here? So as I've done umpteen times before, umpteen apparently is a real word. It's not a word that I usually use. Anyway, so and then another one of these guys in the bottom of this one. There you go. It looks great. So yeah, it looks basically like I just scribbled on my picture. And we want to find the volume of that thing, and we need a radius length. So the radius is the distance from the y-axis to that function. And it is basically an x distance, right? It's this kind of change in x that's right here. Before, here, let me come back up here, we're finding the distance away from the x-axis. It's a change in y, and the change in y is basically the function that's right there. So I'm not going to actually use this function y is equal to 1/2 x minus 1 because I need a change in x. I need a change in x, so I need to solve this thing for x. I'm going to add the 1 over, multiply by 2. So this function becomes, let's see, y plus 1 multiplied by 2. Here, let's rewrite this as a 2y plus 2. Right, so that is the distance from the y-axis to some sort of, I guess, height from the y-axis, if you want to think of it like that. So 2y minus 2 as our radius there. All right, okay. So then, let's go ahead and throw this all into a definite integral for the volume. Don't forget your pi. On the y-axis, we're going from 0 to 2. That's how high that thing went. Right? Just to be sure. Yep, okay. And then our radius function was 2y minus 2 squared, and then dy. So you don't want to use u substitution on this one because you don't have, let's see, well, could you? Let's see, 2y minus 2 would be 2 is a function. You could actually, or we could square this thing out. Let's just go ahead and square this thing out, shall we? Shall we? Yeah, we shall. 0, 2. I would have a 4y squared minus 8y and then plus 4, I believe, dy. And then let's do some integration, shall we? So, you know what? Why don't I just pull out a 4 first? That'll make this thing a little bit easier to integrate. 4 pi 0, 2. This would be a y squared minus a 2y, and then plus 1. Yep, and yep. Now integrate. I'd have a y cubed over 3 minus 2y squared over 2, so just a y squared, and then plus y from 0 to 2. I'm going to make sure I do not forget to plug in my 0 this time. Whew. 4 pi times, let's see, that'll be 8 thirds minus a 4, and then plus a 2, minus, here, don't forget your parentheses so you can distribute it, 0 cubed over 3 minus 0 squared plus 0. Close the brackets. Okay, that's safe stoppable right there. You know, I mean, if you wanted to. Hey, notice that these zeros cancel out, but I still have to remember to add in, no, actually subtract out this 1/3 of 0 that's right there. Anyway, so right there I have, let's kind of do the arithmetic on here. Just kind of, but not really. 8 thirds minus 2 when I combine these two guys. And then 2 rewritten as thirds would be 6 thirds, which makes 2 thirds. 4 pi times 2 thirds, which I believe makes an 8 thirds pi. Yeah, units cubed. Well, there you go. There's your first opportunity of revolving something around the y-axis instead of the x-axis. Did you figure out what piece of candy that this roughly looks like? Well, we can approximate it with a Reese's cup. Is that a stretch? It probably is a stretch, but you can definitely see that this is a solid revolution. You'll have to maybe nibble off all of the kind of knurled edge that goes around that just to make it nice and smooth, because any solid revolution has kind of smooth edges. I'm sure you won't mind nibbling off all those chocolate edges. Do you have any Hershey's? This isn't Hershey's. This is Reese's Cups. Are you allergic to peanut butter? I hope not, because I'm about to give you some hypothetical Reese's peanut butter cups.